Hey guys, what's happening? So, welcome to part 2 of the Klipper conversion for my little ABS printer build here. If you didn't watch the first part, I was looking for a printer that I could actually use to I was looking for more of like an enclosed printer. This printer was given to me by one of my friends, and so it's running like an old version of Marlin. Really, it's one of the really early Qidi Tech printers, but they actually came out with some really nice printers that compete with like the Bamboo Labs. But this printer is, like I said, the more I look at this printer, the more that I like it, the more well built I feel like it is. So I figured this, by looking at it, like if this was a horrible printer, I wouldn't want to spend the time and money to make it like an ABS printer, like a fully enclosed ABS printer. So yeah, right now I'm just getting the parts together. So I got a little Raspberry Pi 3 here. B+, but I'm actually ordering a 5-inch touchscreen. I mean, these little ones, these GPIO pin LCDs are not great, so we designed that, and I'm going to put an SKR Pico in there. It's not a Core X, it's not going to be a high-speed printer, so I don't really need a lot of processing power. This is more of a Cartesian style printer. But it's it's actually very well designed. I think it was a low-cost printer originally. So, I mean, a couple of things I'm looking at are the fact that these are injection molded mounts, and see how far apart they are? They're very wide apart, so that gives it the axis a lot of stability. But even on the X right here too, it's very far apart, right? So it gives it a lot of stability. Here's another side, and it has end stops. And it's up on the Z, so I'm not gonna even bother doing it with a small printer. A lot of times you don't even need a probe, so I'm not gonna even bother with a probe. I mean, I could do click in the future, but I might redesign this head, maybe like a Bondtech BMG style or something like that, or actually probably one of those newer large gear ones. Maybe design something like an all-in-one mount or something. But I've already been designing parts for this thing. Last night I printed out a conversion plate. That's going to allow me to take use the existing mounting holes and then convert it into like a SKR Pico mount here, which is going to like that. But I'll flip it over and I'll show the electronics. And but yeah, I mean, like I said, even like the Z motor, the screw is actually built into the motor. So there's just little unique characteristics that I see on printers that usually improve quality. This thing actually has. And I'm like, okay, well, you know, I was looking on OfferUp to see if I could find a conversion printer, but I was like, oh, all right. So look how thick that's like 6mm thick plate, the aluminum plate. I don't know what this sheet is, but it's some blue. It's not PEI, but I don't know what it is, but I think what I'm going to do is like for $10 or $15, I can get like a magnetic PEI sheet. So, so it didn't actually have the side covers on it. I don't think it came with it. What's weird is I saw pictures of the one without the side covers. I don't think this everyone had it. So they created like this metal box, but then they didn't fully enclose it. But it also looks like there might have been a top cover at some point, because this would hold the top cover. But I never seen a top cover in the pictures at any of these. It's a Qidi X one2. But I do actually have some plexiglass sheets from my 3018 CNC build, the enclosure I built. I designed a full enclosure system for a 3018 CNC print or CNC machine. That's just some stuff on there, so I'm going to cut those out. Give it some side panels, and then, like I said, for the top cover, what I'm thinking about doing is, if I redesign the extruder system lower, then I can just probably put a cover on top and maybe do like a cable chain inside internally that just runs on a cable chain, so I can actually keep everything on here, or I can crack and create like a lid that goes higher. I mean, either way, I can do whatever. It doesn't make a difference. But I don't know if this is a dual drive extruder or not, so I don't know what's in here. But in the first phase of this printer, let me flip it over. I just flipped it over. So what I was saying is like the lead screw goes in through the motor. So this is typically will give you less wobble when the actual lead screw goes straight in the motor. I mean, they even use like now it's upside down, but They use really nice ball bearings, like the very long ball bearings, so that gives it more stability. Just little things like that. I mean, I noticed that they could have gone a lot cheaper, you know. Alright, so it's running a Meanwell power supply, so that's cool. Now the main board, originally I was thinking maybe I could find the specs for this main board and convert this to Klipper, but then I was like, I already have extra boards because there's no, they don't even have an uncompiled version of Marlin, so it doesn't make sense. It would take me too long to go and try to figure all the pinouts of this thing and try to recreate it in Klipper. So really no point. So yeah, then also has this ribbon LCD. So it's yeah, the firmware is really hard to get in this thing too. So actually, this motherboard sells for a lot on eBay. So I might resell that. Who knows? But yeah, the adapter will go here. I'll show it to you. I'm gonna get the adapter in here. So yeah, I forgot to mention this thing. Even already has an LED strip, so that's super cool. So I think the swap would be pretty easy. Like I said, I have to design a new front mount for the 5-inch LCD I have coming in, DSI LCD. But alright, so it looks like a 4M4 screws. You know, I could do like sensorless humming, but it doesn't make sense when you already have end stops. End stops are always going to be more reliable and quieter than like a sensorless humming. It's usually more accurate too. So they're already run, so I'm going to just re-terminate these to JST connectors. So here's the adapter plate. So what I did is I modified it because I wanted to add a buck converter here to power the Raspberry Pi. That way I could actually have it as just one power plug, and everything comes on. I don't even have a separate power port for a Raspberry Pi. Yeah, I also have it's adjustable, so I can adjust to like 5.1 volt. Because I'm going to be drawing extra power, because I'm going to be running an LCD, 5-inch LCD, and also a Pi camera. Or, I mean, I'll make a USB camera, I'm sure. I already have some Pi cameras. Alright, so I'm going to move these over. Power, I'm going to try to keep them in as much as I can. Fans and stuff. It's not really, I mean, there's labels on there, but I'm just going to look at them. So we got power here. What's that? Okay, main power. Obviously, that's probably the hot end right there. Alright, so I'm going down a little bit, but got everything moved over. Power. Heated bed. Hot end. These are the different end stops. Thermistors. Fans. And then the steppers. Let's fire this thing up. So I actually copied the configuration of my printer about here. It's a similar end stop issue where the Y goes in the back. Instead of going forward, it goes back, so it end stops in the back. The X is pretty standard. Alright, let's fire this thing up, see how that goes. Alright, got some power. Alright, got some red light on the board. Alright, so now I go through, configure the fans, motors, the humming routines. Yeah, I'm probably getting the air already. Yeah, this 3.5 touchscreen, I've had it for like probably 10 years, but it's never been great. It's always been a headache to either configure or set up. Just it's not really responsive. I think it was like 20 bucks like 10 years ago. Alright, so I got it on. I had to unplug the thermistor on the hot end. I don't know what it actually is, what type of thermistor it is, but it looks like it's a standard V6. But alright, so today is a new day. So last night I got everything working, the motion going. I'll show you that, but got the heated bed working, but I'm having issues with the thermistor on the hot end here, so I need to figure. I'm gonna flip it over and do a resistance test and see what. So a typical at this normal temperature, I usually get a reading of about 80 to 90K for a 100K resistor, because it's around my area. It's around 25 degrees Celsius. All right, we'll flip it over. So here's the thermistor wire. So I actually unplugged it because it was actually preventing my the MCU or Klipper from firing up altogether. So I should say the ambient temperature is about 25 degrees C typically here, which is around. I live at the beach, so it usually stays around 75. All right, so I'm gonna take a resistance reading right there. Yeah, so I'm gonna do a little odd reading here. It's hard for me to get it on there, but getting about 18 degrees when I can get it on there. Yeah, that's pretty odd. I'm getting 18 ohms here. Yeah, pretty interesting design. So that's the main heater block, comes up here. And then there's like a fan that comes up here. I mean, obviously this weight of this NEMA 17 is not doing you any favors here. Just added weight, you know, reduces speed. Alright, let's see here. The spring loaded action here. So I mean, obviously it's not gear reduction because this wouldn't, I mean, it's the path here. Alright, so that means it's single extruder. I mean, there is benefits of having a single, not a dual drive, you know. But alright, so I got to figure out the thermistor thing here. Maybe it's just not crimped right. That just seems weird to have 18 ohms. Alright, so I mean, everything has been pretty straightforward in the conversion, except for this. Hopefully you can see that in the camera. Maybe that's too much light. Well, that's actually not a thermistor. It's a thermocouple. So I'm trying to figure out what kind it is, if I can even, it will even work in Klipper. I know, like, the main board here, it's, I mean, I see this little connector that says N. Yeah, there's like basic, this is called a Qidi board. So this one's called K-therm. Probably can't see that. The green connector right here, that's for the thermistor. Well, it's not thermocoupler. So I wonder if there's a separate chip on here on the PCB. I'm gonna put this on my microscope and see what's up with that. But I might have to change that. It's actually threaded in there too. It's not even just like clipped in there with like a set screw. So yeah, this is the only major thing I've seen so far. This is the only thing I can't get working right now. Is this right here. So, alright, so I looked at this on a microscope here, and you're probably not going to see it, but this is a MAX6675 chip. So you're never going to get that to be able to work on one of these smaller, cheaper boards. So you'll need one of those chips to control it, and it works via SPI. So yeah, that will never work with the SK or Biqu. So, you know, I really like this carriage design. It's very smooth. Like, these bearings are incredible. Like, it feels extremely smooth. So I might take some of these ideas and move these over to my Celeritas printer. These are actually a lot smaller than your typical LMU8 or LM8UU bearings. Yeah, they seem a lot smaller, but they feel very smooth. And not very noisy compared to those other ones. You know, those other ones are crazy noisy. Alright, so I got everything configured. I made another video about this touchscreen that I installed and designed, the case and bracket. All this stuff will be on my Thingiverse page. But it's running off a, what's it called, like a buck converter that's fed to the GPIO pins right here, the power. I'm still going to button up the wires. I'm not done yet because I still got to do stuff, but this will be the end of part 2. Let me flip it back over. Here's the screen. If you didn't see it if you're not subscribed to my channel, that's the screen I just installed. $27 on Amazon. Alright, so I went to the store and found an incredible deal at Micro Center. It's what's it called? This thing was $10 on sale. I guess they were kind of phasing it out, but this is the Biqu H2. And I just couldn't believe it was $10. Originally it was like $90, and I guess they were just doing clearance. I mean, they have newer versions of the same extruder. This is the version 2. But remember what I was saying? That I wanted something low profile with a cable chain. So I wanted to be able to fit. I wanted to keep as much as, because it's going to be high temp enclosure, right? Not super high temp, but I wanted to keep as much as the ABS plastic as I could on there, because it runs so smooth. You know what I mean? It's like perfect. Like I said, this wasn't a very well built printer. I wouldn't even bother with it. But just the sturdiness of this case, you know, and ABS plastic and how smooth it is. I mean, this is going to be a good printer when I'm done with it. Yeah, I don't know why they use that proprietary firmware. That was weird. Qidi, you know. Alright, so I'm going to probably take those notches off, and that'll be the third video. I got to get this installed. Get the cable chain going here. But yeah, I wanted to get everything below, so I could fit the cable chain below here, so I didn't have to make like some high cover, you know, it'd be flush. So I want to make this a little cable chain, and alright, so that'll be in the part 2. So yeah, I got to feed up. I mean, this was an incredible deal, $10. Came with a fan and all like the thermistor and the heater cartridge, the whole thing for $10. But what's funny is I was going to go back and buy more, just to have them. I mean, they're tiny little Nemo 14. They're tiny, but they were sold out like that. There was 6 in stock, and then I just happened to see it that one day and bought it, and it was instantly gone when I went back to look on the webpage again. So I kind of lucked out there, but all right, cool guys, having fun, awesome. All right, so that's gonna be it for part 2. But let me share a quick little hum real fast. I basically have to do that because the part's not there right now. All right, this is gonna be a cool little printer. All right, awesome, having fun. All right, cool.